Now let's discuss question number 29. This question is from chapter Triangles. The question says, prove that in a right triangle, the square of hypotenuse is equal to the sum of squares of the other two sides. This is the statement of Pythagoras theorem, and this is given in your NCERT book in form of theory. Now let's derive this result. First of all, here we have the given information. A right triangle ABC is given, which is right angled at B, and you have to show that the square of hypotenuse is equal to the sum of the squares of other two sides of this right triangle. For proving this result, we need construction. We have to draw perpendicular from vertex B to the opposite side, that means hypotenuse of this right triangle. So here BD is perpendicular to AC. Now we will use the concept of similarity in two triangles to derive the required result. So in the first step of solution, we are taking triangle ABC and triangle ADB. In two triangles, angle BAC and angle DAB are common angle. Angle ABC and angle ADB both are equal to 90 degrees. That means using angle similarity criterion, you can write triangle ABC is similar to triangle ADB. And friends, you have studied when two triangles are similar, their corresponding sides are proportional. So in the next step of solution, you can write AB upon AD is equal to AC upon AB. And when you cross multiply, we are obtaining AB square is equal to AD multiplied by AC. Mark this relation as an equation number 1. That means here we have obtained the square of one of the sides of this right triangle ABC. Similarly, we are going to prove the similarity in triangle BDC and this complete triangle ABC. So in the next step of solution, you can write similarly triangle ABC is similar to triangle BDC. Again, when two triangles are similar, their corresponding sides are proportional. So you can write BC upon DC is equal to AC upon BC. When you cross multiply, you will obtain BC square is equal to AC multiplied by DC. Mark this relation as an equation number 2. When you notice this equation carefully, this is the square of the base of this right triangle ABC. That means in equation number 1, we have obtained the square of perpendicular. In equation number 2, we are obtaining the square of base. And when you add equation number 1 and 2, what you will obtain? It would be clear from the next step. So here we are adding equation number 1 and 2, and on the right hand side we are getting AD multiplied by AC from equation number 1 and AC multiplied by DC from equation number 2. You can take AC common from these expressions and you are obtaining AC multiplied by AD plus DC. AD plus DC will be replaced by this hypotenuse of this right triangle ABC. That means we are obtaining AC square on the right hand side of this equation. And when you further modify this equation, you will obtain the square of hypotenuse. That means AC square is equal to the sum of the squares of the other two sides of this right triangle. This is a way by which you can derive this Pythagoras theorem. I hope you understood the derivation of this Pythagoras theorem. Now let's discuss the marking scheme of this question. So start from the beginning. When you draw the diagram and write these information, that means the given part, to prove and the construction, this will give you 1 mark for this question. Clear? And when you prove the similarity in triangle ABC and triangle ADB, this step will give you another 1 mark. Clear? And when you find the value of AB square, that means equation number 1, this step will give you half a mark. And when you show triangle ABC is similar to triangle BDC, this will give you another half mark. And when you find the value of BC square equal to AC multiplied by DC, that means equation number 2, this will give you half a mark, and rest half mark for the final result. So I hope you understood the solution as well as the marking scheme of this question. Now let's proceed to the last question of this paper.